Okay, good morning. Welcome to
MathyMath number 44.
MathyMath number 44. So this is problem 25 from the 2006 AMC8, and you just didn't get to this problem this morning because of time. You ran out of time, so that's fine. It's a neat problem, so I just wanted to go over it. Here's the question. Barry wrote 6 numbers, one on each side of 3 cards, and he laid the cards on the table as shown. The sums of the 2 numbers on each of the 3 cards are equal. The 3 numbers on the hidden sides are prime numbers. What is the average of the hidden prime numbers? Okay?
Alright. So, I'm going to call the number on the back of this card number P.
Okay.
Then the number on the back of this card is P minus 15. Number on the back of this card is P minus 21. Well, actually, I don't know that.
Okay.
Do I? No. I think it's plus 15 and plus 21, because they all have to add up to the same thing.
Okay. Yeah, and how do you know this one, this number on the back of this card is larger than the number on the back of that card?
Because the number on the front is smaller.
Okay.
So, our average is going to be 3p plus 36 over 3, which is p plus 12.
Okay.
So we need to figure out what p plus 12 is. Did you give us any other information?
No, it did give you the answer choices. If you're going to approach it this way, this is an interesting idea from the answer choices, because you've identified the average, and the answer choices were 13, 14, 15, 16, and 17.
So I could try doing it from the answers. Start in the middle. P is 3. P. Oh, but this one isn't prime. And neither is this one. That leads me to believe that P has to be 2.
Why?
Because you're adding an odd number to the prime, and you have to get a prime number.
Wow. Very good observation. Why do you have to get a prime number when you add them together?
When you add P and 15, or P and 21.
Oh, you have to get a prime number?
Well, it said this number's a prime.
Oh, yeah, right.
Prime,
P and
prime.
P plus 15. I gotcha. Yeah, I see what you're saying. Sorry.
So, this would end up, if P was 2, this would end up being 17, 23, and 2.
Okay.
And then the average would be 14. This case is the one that works.
Interesting. There you go. Well, that's actually a nice solution, even though it uses the answer choices as a choice. If the answer was 13, the P number would have to be 1, which is prime or not prime?
Both. Well, it's by definition not prime.
Okay, by definition not prime.
It technically is prime.
Why do you say that?
Well, because it's only divisible by itself in 1.
But it's not prime
By definition, yeah.
Okay, so 14, P would be 2, definitely prime. 15, P would be 3. So maybe we have to check. And you did, and you found that this one wasn't prime. 18
And
is
that
prime,
one wasn't
24 is not prime. 16, P would be 4. P plus 12, is that prime?
No.
17, P would be 5, that is prime.
Run into the same problem as the
You're in the
15.
same problem. Okay, that's interesting. But the real point of the solution is the other thing you said about evens and odds. Because the sum with primes, the three primes are going to have to be different numbers. Why?
Well, because they have that add up to 59 plus p.
Okay.
So they can't all be the same prime.
Okay. Most primes are odd. Odd, odd. So that would mean this would have to be an even number added to 59. So there's an even and odd idea. It's actually a very neat problem. It's a cool one to think about.